Okay, let's look at example 6 on page 10. Now, we're given the problem f of x equals 2 over x plus 1, and in part A, we're asked to find the average rate of change between x equals 1 and x equals 4. And the way we're going to do that is we're going to find the value of f of 4 minus the value of f of 1, and then we're going to divide that by 4 minus 1. So what we're going to do is take x and replace it with 4 to get 2 over 4 plus 1, and then we're going to replace x with 1 for this part here and get 2 over 1 plus 1. Then we're going to divide all of that by 4 minus 1, which is 3. Well, this becomes 2 over 5. This is 2 over 2, and 2 over 2 is just 1, divided by 3, where 2/5 minus 1 is a negative 3/5 over 3. Now here, we're dividing fractions here, and to divide an improper fraction like that, you flip the denominator and multiply. So this now becomes negative 3 over 5 times, instead of 3 over 1, this becomes 1 over 3. The 3's cancel out and we end up with negative 1/5. Therefore, that's what these 3 dots mean. The average rate of change is negative 1/5. Now for part B, we're looking for the instantaneous rate of change, and that's at x equals 1. Instantaneous rate of change at x equals 1. Now sometimes I put an O in there and sometimes I don't, but I know what it means there. Now to do that, we're going to write it this way. The limit as h goes to 0 of f of x plus h minus f of x, all divided by h. Now what this is telling us is to go back to this original equation here, and wherever I have an x, I'm going to replace it with x plus h, and for this one I'm just going to rewrite the equation the way it is because that's just f of x. So this becomes the limit as h goes to 0 of 2 over x plus h plus 1 minus 2 over x plus 1. And remember, all of this is divided by h. And these rational functions, if you forget that, it isn't going to turn out very well. Over h. Now, like any fraction, if you're trying to add or subtract them, you have to have a common denominator. Now, one way to get a common denominator is to multiply each one by the alternate denominator. So what I mean by that is I'm going to take 2 over x plus h plus 1 and take this denominator here in the second term and multiply that top and bottom. Now that doesn't change anything, because unless x is negative 1, x plus 1 divided by x plus 1 is always going to be 1. And over here I'm going to take 2 over x plus 1 and multiply it by this denominator here, x plus h plus 1, top and bottom. And it's still divided by h. Okay, so the limit as h goes to 0, and 2, I'm going to multiply the numerators, 2x plus 2 minus 2x minus 2h minus 2 in my common denominator, and I'm not going to expand the denominator out, I'm just going to leave that the way it is. It's easier to work with. Over x plus h plus 1 times x plus 1. I only wrote it once because it's common to both terms here, and I only need it one time. And all of that is divided by h. Now, once again, I've got this improper fraction, so I'm going to invert it and multiply. And I will get, let's clean this up a little bit first. The 2x disappears, the 2 disappears, and I'm just left with negative 2h over x plus h plus 1 times x plus 1. And this is all divided by h, and that's really h over 1. So I'm going to invert it and multiply by 1 over h. Now when I do that, look at what happens here. These h's cancel out. They're gone. So I'm left with the limit as h goes to 0 of negative 2 over x plus h minus 1, and you can't see that, so let me move up a little bit, over x plus 1. Now let me go over the part I did when you couldn't see it. Okay, we expanded this numerator out. 2 times x, 2 times 1 gives me that, minus 2x minus 2h minus 2 times 1. And then I clean up the numerators here. 2x minus 2x is 0, 2 minus 2 is 0, and I'm just left with a negative 2h. That's what this is. Now this is all divided by h, and I wrote this as h over 1 because it's an improper fraction. Now to simplify it, I have to invert the denominator and multiply, so I flip this to 1 over h. The h's cancel out, and then I'm left with this. And now I'm going to let h go to 0. Now when I do that, this disappears. I no longer need this limit sign because there's no h left in there. Now I have negative 2 over x plus 1, plus 1 times x plus 1, and I can write this as negative 2 over x plus 1 squared. Now I want to find the instantaneous rate. Let's write that. Therefore, the instantaneous rate of change is negative 2 over x plus 1 squared. So when x equals 2, I get negative 2 over 2 plus 1 squared, which is negative 2 over 9. So that's my answer, negative 2 over 9. Now for part C, page 10, example 6, part C, I want the tangent line. When x is equal to 2. So I know what my slope is. My slope is going to be negative 2/3, 2 over 9 rather. That's m, not n. Now if x is 2, I need to find f of 2. That's my y value. So this would be 2 over 2 plus 1, which is 2/3. That's what y is. Now the point slope formula says y minus y naught equals m times x minus x naught. So this is my x naught here, and this is my y naught, 2/3. So y minus 2/3 equals my slope, negative 2/9 times x minus 2. So let's clean this up a little bit. Negative 2/9x plus negative 2/9 minus 2 is going to be plus 4/9. Add 2/3 to each side. Now 2/3 is the same as 6/9. And my equation becomes y equals negative 2/9x plus 10/9. Now let's check this and see if it looks correct. Let's clear everything out. Second plus 7, 1, 2. Go back into the equation editor. This becomes 2 divided by x plus 1. My tangent line, I believe, is going to be negative 2 divided by 9 x plus 10 divided by 9. Now if we graph this, let's see what we get. Hold it up a little bit, get a better view on it. There you go. Now let's square the screen here. So zoom 5. It looks a little better when it's squared. Okay. Now here's 2, and you can see that's the point of tangent. See where the tangent line crosses that. So it looks like we're good on that one. Okay. Takes care of number 10. Now let's go to page 4. Better yet, I'm going to stop here on this one. Then I'll make a different video for the